On this episode of the Decision Intelligence Lab podcast, we welcome Peter Cacioppi from Decision Spot. Peter talks a lot in this interview about the connection and the importance of connecting model building and production software development. He talks about some tools that he's developed and used, about the importance and the value of Python within the Gurobi ecosystem, and speculates a little bit about how LLMs are changing the software development workflow, especially around optimization. If you're interested in the challenges associated with bringing production models to life, especially in real-time environments, you're not going to want to miss this episode.
You're going to need somebody that understands the art of modeling, somebody that looks over the math, the Python part of the code, understands what's going on there. Because if they don't, I think you're going to end up with like a bug that gets created by the LLM, and the LLM keeps hallucinating on how to fix that bug, or the bug doesn't get captured, right? I mean, I'm always impressed by where LLMs are really well trained on the world of Python. And in fact, I've kind of gotten to the point where I don't do a ton of Python research right now. I have conversations with the LLM.
All right, today we're joined by Pete Cacioppi. I've known Pete since 1998. We've worked together in a variety of roles, and I think we competed with each other at some point. We brought Pete on because one thing we want to talk about in this podcast is successful implementations of OR, and Pete brings a nice perspective from the software engineering side. So Pete, welcome.
Yeah, thanks, guys.
Yeah, let's start off with some of your strong opinions. So I know you have a strong opinion on the fact that OR people, optimization people, need to bring ideas from computer science into their projects. Can you expand on that or explain sort of what you're thinking about there?
Well, here's my sense of it, right? So I don't want to be the sort of person that says programming is for everyone, right? Because I definitely agree that there's like lots of people who are very smart, but also just aren't interested in the kind of abstract logical reasoning associated with programming. But if you take the subset of people that are good at math, then they're already really good candidates for programming in general, and Python in particular, right? Because Python is the language that was worked out that was kind of well vetted by computer scientists. So it has a lot of logical consistency. It's easily tied back to mathematical concepts. Like if you have an OR student, somebody that's done quite a bit of math by the age of 22, that person has been familiar with the concept of a function since they were a child, right? Yeah. The idea that, let's take a function, from a function, let's make another function. That was something they probably learned, I don't know, like around age 14 or something, when they were right. Like, yeah, that's a derivative. We're taking a function and making another function. So, so if that person is playing around with Python and they encounter somebody like me who says, okay, what you need to do to plug into my world is to make a function that takes these sorts of inputs and returns that sort of outputs, I'm just skeptical at the idea of this mathematically sophisticated 22-year-old is going to be afraid of that requirement, right? That's just like that. For that person, it's not going to be a blocker, right? And so that's kind of the theme that I take through all of the sort of programming instruction that I try to promote, which is that just going from sort of hacking around Python into something that's arm's length of professional Python is not a big requirement. It's something that's relatively easy to explain. It really amounts to a set of checkboxes that you just have to be aware of, and I've seen some examples. And then, especially now in the area of LLMs, I mean, if there's any ambiguity, you're not in the area of LLMs, you don't really have to follow my guide at all, right? You could just like understand the ideas that I'm talking about and then have a conversation with ChatGPT or any other LLM about, I want to check these boxes. Pete says do it this way, but I'm skeptical of that way.
Yeah.
If ChatGPT steers you slightly differently than me, it probably, I don't think it's going to steer you wrong. So, but more is that these sets of requirements are fairly mechanical, right? And so people talk about, the art of modeling. The art of modeling is a sexy idea. And that does seem to be a thing that the OR community is interested in teaching. And what I'm saying is the part that I'm interested in teaching is really the anti-art of modeling. It's a more of a minimalist mechanical set of steps that you just plug onto your, that you plug into your workflow when you're migrating from, say, hey, I've got this Jupyter notebook mathematically, it does what needs to be done. Okay, how do I migrate from Jupyter notebook to something that can be recognized as real software? That part is like fairly mechanical, not that hard, just consists of a few checkboxes.
And if OR people did that, what benefit would they get?
I mean, there's a lot of benefits, right? One of which is that you could just interact more pleasantly with the world of software engineers, right? So it's just like if you're interacting, if you're trying to plug into a tech stack and you say, "Hey, I've prepared this thing. It's a wheel file. It has obviously a small number of carefully chosen public subroutines. Its input, it validates its inputs. It takes pandas data frames as inputs, but in a very smart way. In other words, if you make some kind of silly mistake with the pandas data frame, it doesn't just quit or give up on you. It actually gives you good feedback when you, my fellow programmer, who's more of a software engineer, makes some kind of, or passes along some data that needs to be cleaned up, right? My code doesn't crash on that ungracefully. And then also it's well tested. That's for your benefit or also for somebody else's benefit when they take over your project, right? I mean, projects evolve. You're not going to, especially with optimization, I don't think you're going to get this like super clean set of requirements at the very beginning and then nobody's going to ask for anything ever again. And so every time you're making an update, you're going to rethink your code in order to add some new feature. You want to make sure the process of refactoring will simply make you a better programmer all by yourself, right? The idea of, before I even add this new feature, I'm going to reorganize my code to better fit this new feature. And I want to make sure when I do that reorganization that everything, it keeps doing the important things that it was doing before. That's why you have a test suite, right? So that's kind of the checkboxes of tidy tested safe. Like I was in a meeting one time where it was kind of interesting. The engineers I was working with were reluctant when I said, "Hey, I'm just going to give you guys a wheel file." And they're like, "Oh, we don't want a wheel file. We don't want a wheel file." And there was this manager who had previously been an engineer who throughout the meeting up until that point was quiet. And then he unmuted himself and said, "Knock it off. Just take Pete's wheel file. That's fine." And then, so it's a nice thing to, these basic software engineering practices, even if they're not universally 100, like nothing in the world is 100% recognized by everyone. Right. They really are the best practices, and you are likely to find yourself on good footing if you follow them.
Well, Pete, I am that OR guy who doesn't like to code and has gone out of his way to avoid learning a whole lot about coding, but everything you've talked about is really key in terms of getting my work into production. And so I sort of have to learn, and I want to learn your concepts of tidy, tested, and safe. I felt like you went over them a minute ago quickly, but can we break them down a little bit?
Sure. And also, I don't want to say I'm not necessarily saying everyone has to do this. I'm just saying at some point, someone on the team should be doing this, right? So it's like if there's if it's a collaboration where there's somebody who says, "Look, I'm just happy making these Jupyter notebooks. Do you have to hassle me with this nonsense?" I've been on teams where I was like, "Yeah, don't worry about it. Just keep making those Jupyter notebooks. Keep sending me newer Jupyter notebooks. I'll keep doing these other things.
Sure.
We'll make for a great team." So it's not like it's more like these are some good minimal checkboxes for production code, as opposed to a thing that and also if you're nervous about learning this stuff, I honestly don't think it's that hard.
And I'll add to that. Like if you're a leader too, I would think that things you're talking about here, someone on the team needs to be thinking about these things. Someone needs to do the things you're talking about. That's kind of also what you're saying, Pete, right? It's like, let's just watch out and make sure someone's doing this so that we can get this thing into production.
Yeah, exactly. It's like teams can self-organize it. I try to be respectful of people having different sort of brains and liking and not liking to do different sort of tasks. Like I worked with Mike before, and at one point Mike was like, "Pete, you're terrible at making PowerPoints." And I was like, "Yeah, can't I just be on the team and not make any PowerPoints? Can I just make ugly PowerPoints and pass my ugly PowerPoints to some other person who turns them into pretty PowerPoints?" And, Mike's response was, "Yeah, sure, we could do things that way." And you could do the exact same thing with code. Somebody could just be like, "Yeah, I know, I'm not doing any of these hygiene things. It's kind of a mess, but it works. Can somebody clean it up?" Yeah, if there's somebody else on the team that's happy to do that, then the whole process works fine. It's more to the point is don't be presenting these ugly PowerPoints and pretending they're not ugly. Don't be doing the code equivalent of that, right? Because it's like, yeah.
Yep.
So so again, I broke it up into tidy, tested, safe, to try to have three, because people remember things in three, and there to some extent there's some independence between the three things, and so tidy is more conform to sort of high level Python best practices, which the first checkbox is, it's not that hard to make a wheel file, so you can make a wheel file. It's if you're going by a wheel file, you make a Python package. That's the easiest way to think about it. Like you're try to organize your code so that it's a Python package, then learn enough about Python so that you can create a simple wheel file from your Python package. Honestly, I usually make very simple wheel files. I usually make wheel files that don't install anything other than my own code, because I've worked with engineers that would rather not have a math nerd messing around with their Python environment. So I'm like, and I kind of think that. So I have a requirements text file, but I don't build it into the wheel file. So my wheel file is very minimalist, and then somebody can then go look and see what other things probably ought to be installed to make it work. But at least at minimum,
let me ask about a wheel file real quick. So a wheel file, same as a Python package, kind of similar.
I'm kind of using those terms. And yeah, a Python package is the thing that you're like, with pandas data frames, you're importing a Python package, right? And so I'm saying you're not going to be putting your Python package on PyPy because that's public, right? Whereas pandas is on PyPy because it's public. So how can I share mine? The two obvious ways are you can make a wheel file, or you could have a nice clean GitHub repository that mirrors the structure that you would use to make a wheel file, and then other people on your team can access your GitHub repository. So do one of those two things. And obviously, if you're working with people that aren't going to be looking at your GitHub repo, then it's just a few extra steps to make a simple minimalist wheel file.
Okay, so if you're writing an optimization program, like the linear program would itself be a wheel file, and then maybe you have another wheel file for the input and another wheel file for the output?
No. Make a nice tidy. I mean, I have examples of this. Like I demonstrate this with. This is one of my ideas, that when you teach people this stuff, you can make it very clear. You can have very, very simple MIPS, and you can do all this production kind of stuff with very, very simple. Simple canonical programs. And in fact, that's a thing that kind of gets me irritated when I talk to other people about how to teach this stuff. They're like, oh yeah, I demonstrated this with this like super complicated thing. And it's like, no, that's not the way you teach people. Like you teach people like, oh, hey, you understand diet? You understand? I mean, the way to start is the diet that Gurobi invented a long time ago. Like Gurobi did a great job with like, okay, here's a diet file that doesn't, a diet.py file that doesn't, where you don't have to worry about any of this other stuff. Like, don't worry about tidy, don't worry about tested, don't worry about safe, just get the math done and worry about like how to model things in the world of Python. And Gurobi kind of nailed that, both with how their Gurobi Py package looks and, the basic example diet file. So people can start there. They understand that basic Gurobi example for diet that has none of the tidy tested safe things. And then with diet, just keep adding more industrial things onto it until you have a tidy tested safe version of diet. Anyway, I have two examples of like, oh yeah, here is diet in tidy tested safe format. And when you install it, it's a Python package that handles the input. It has a clean subroutine, and it also has a way of reading from data files on your local computer. So it can either, for another programmer, it's like, oh, here's a nice clean subroutine that's robust with when you pass the data. And, oh, I just have Excel files, I want to play around with it, there's a clean command line interface for, okay, how do I read from an Excel file and write back out an Excel file? So does that make sense?
Yeah.
Okay.
All right, so let's get back to tidy, tested, and safe.
So yeah, tidy, I would say make a package. I probably should have started off with that explanation instead of a wheel file. Make a package, put everything inside of a package, have a minimal number of public components in the package. And then this was sort of bleed tidy into safe a little bit. And this is why I invented Ticdat, whatever, was as part of tidy, I programmatically make public what my solve function needs. So again, with diet, there's a solve function which takes the diet input data, as, for example, as pandas data frames, returns a solution. If you want as pandas data frames, there is another public part of that package that says, oh, this is the input schema. That describes what you pass to the solve. So that way, anyone with a passing knowledge of Python can then figure out exactly what the data frames I need. Now, obviously, there's examples that you can look at for input data, but also it's nice to be able to just look up columns and fields and say tables and columns and say, oh yeah, there's a foods column. The foods table has a cost column. The cost column has to be a number, has to be a positive, has to be a non-negative number, that kind of thing, right? So so safe kind of bleeds into tidy a little bit, in that I make my safety requirements public and easily accessed by another programmer. But in general, what safe means is that I'm not just going to collapse in a heap. My code just doesn't give up when there's some, data integrity problem. Here's, one example that's unsafe, And all you have to do to break this, to make it brittle, is to add a duplicate row into a pandas data frame. There's two guys named Vincent, the whole thing blows up, right? As opposed to what Ticdat makes it easy what Ticdat facilitates is making it easy to do things like, let's do a check to make sure there's no two guys named Vincent before I do my fancy math. So that's safe. And then finally, tested. Again, I don't want to draw people into long, elaborate computer science arguments about let's do very fine-grained unit tests. Let's make sure every little subroutine has its own unit test. What I'm talking about, the minimal set of requirements here is just, you have that public solve routine. It's just a natural thing to have a test suite of data for that public solve routine. I mean, if somebody else has built an optimization routine and they sent it to you, and the first thing you'd want to do is run it. To run it, I need some data. Okay. It's a very small step to go, I have some data for it. Oh, the data is part of my test suite. The test, there's a testing suite, there's a data section. The testing suite, what it does is it goes and grabs those data sets from the data section, runs them, and validates that the top level KPIs are what you expect it to be, and runs a solution validator. If you're, you can go and onto my LinkedIn page, and I talk about a solution validator. Yeah, we don't have to get into the details. Whether or not you get it, I mean, if you've gotten to the point where you're making solution validators, you're already like my ally, right? You're already my comrade in like 99% of these things. So at that point, it's like, I don't have to convince you of anything. So, my point is more like, what is the point of creating this, sharing it with somebody and not sharing the data? You should share the data, right? The person's going to want some data. It's not that much extra work if you're going to organize the data in with your code and turn it into a testing section. That's just a tiny amount of extra work. And then now your code actually has the value of testing.
Mike, you want to ask, because Pete brought it up already, about Ticdat?
Yeah, I'm going to come back to testing too, but let's ask about Ticdat. You brought it up, and so what is Ticdat? Like, what does it stand for? Why did you create it?
Yeah, I mean, are you guys okay with me kind of going into like war stories a little bit? I think this is important.
We're dying for war stories, Pete.
Yeah, war stories
are dying. Yes, go.
Yeah. So I think this is important history because this is an odd part of history. I think it's kind of says something a little bit about the OR community, that I think there's a part of history here that's like very under-recognized, right? So specifically Gurobi, back in the day, back in like 2012, 2013, they were definitely pioneers in the Python space. I mean, I think I mentioned this already, but let me emphasize that point further. Like, I got into Python relatively early. Like, I think we had this conversation back then, Mike, 11 years ago, where you were like, I don't know, Python R. And I was like, no, it's got to be Python. And the reason I was excited about Python was because Gurobi was excited about Python. So specifically, I watched Greg Glockner had this video up where he was loading his Python code into like an something equivalent to an IPython window. Then he was loading his data up in there. And then he was doing all this like little like 2-line programs to explore like, okay, this is where, look, I can play around and see where the infeasibility is. I was like, this is amazing. Like, this guy clearly has it. This is clearly the future, right? This is clearly some warp speed, the next level thing that's going to make us all much better programmers. And then, I poked around online and saw he wasn't the only one. There was a growing community of people who were like, yeah, this is great. And they weren't just saying, hey, this is great. They were doing things equivalent to what Greg was doing, which is like, let me go through the details of why this thing is so great. And so, Ed Rothberg and Greg Glockner, they really, I mean, I don't know the details of it too much. I mean, and, I don't, maybe too strong to say they bet the company on that, but it kind of seems like they did to me. Cause I mean, they didn't make anything like Ample of their own. They didn't have their own math modeling language, which I'm sure people expected them to do that. Right. Because Cplex had their own math modeling language. I'm sure people expected them to have their own math modeling language. And instead they said, no, we're going to make a great package for Python that's going to, and then Python plus our package GurobiPy will be our modeling language. And I really thought that was, kind of, I don't know, a very, this is like to my mind, this is a great visionary decision. Everybody else followed them along, right? Like Cplex followed them along. Express followed them along. The only people that were there ahead of them was Stewart with Pulp. And, I think, personally, I have a lot of respect for Stewart. I kind of think the Gurobi pi idiom is the cleaner idiom. The idioms that Greg and Ed invented back in 2013 were the cleaner idioms, and so when I came on the scene,
for what it's worth, Pete, it totally makes sense. Knowing Greg and Ed both really well, they're both CS guys first.
Yeah, sure.
And so that makes perfect sense.
Yeah. And to be fair, I think they also had pulp they had Stewart's project pulp to look at, right? So I think they probably looked at that and were like, okay, some of these ideas we're keeping and some of these we're changing, right? So and then the other companies, I think they copied Gurobi more than they copied pulp. I mean, I think I think we can all agree that the Express and the Cplex APIs that came along later definitely made sure to line up with a fair amount of the things that Gurobi invented. So anyway, when I started looking over their examples, I was really like learning how to do Python, learning how to do MIPS all over again. So I was like, oh wow, it's like I'm back to being a college freshman or something. I have to approach it. My C++ techniques are like no good here. This is a new ball of wax. And so I was really learning from Greg's examples, and Greg's examples were also referencing Ample. So this is finally answering your question. When I went through Greg's examples, I was like, what he's really showing is how Gurobi pi can really do the work of the mod file. If you look at how Ample does its thing, how Ample works is it has this mod file dat file pair, and what Greg is really nailing is the mod file, but there's kind of missing logic that in Ample would be handled by the dat file. And so I was like, what he could use is a completely independent package that doesn't connect with Gurobi pi at all, doesn't really require Gurobi pi, could work just as well with pulp, but will do a lot of the logic that in Ample would be handled by the dat file, which means the logic of I'm going to predefine my requirements and I'm going to apply sanity rules on the requirements. I mean, that's, it's a long time back for me remembering how dat files worked exactly, but that was definitely my thinking at the time. It's like, dat files actually make it pretty easy to predefine what you need and to apply sanity rules like, hey, this thing has to match into that thing like a foreign key. This thing has to be a number. It has to be in this range. Like all that sanity checking stuff, that they did a pretty good job of that. And I was with Ample, and I was like, we don't want to lose that when we're moving into the Python world. So that's the history of how I built it. And I never intended to sort of push out. I think there was some miscommunication, and I feel bad because maybe there was some miscommunication and some, hurt feelings with Greg and Ed. I never intended to be like, oh, those examples you have are no good. You got to replace them with my examples. It was more like, I really think the pedagogy should go this way, where people start with the examples you have now. And then if they want to move closer to production, they should use Ticdat to help facilitate the process of, I didn't have the term tidy tested safe at the time, but to help facilitate the process of being more production ready, to include, look, programmatically defining and validating your inputs. This is not like an idea I'm inventing, right? There's a reason why Ample put it into their language, right? It makes their process work better. This is something useful from the modeling languages that we shouldn't lose when we're entering the world of Python. So that's the history of it. That's not really the way I would describe it to somebody now if they wanted an elevator pitch, right? If somebody wanted an elevator pitch now, I would say, hey, I would say, hey, you know how you want to write this subroutine that takes like 5 pandas data frames, and all those pandas data frames have to meet all these fussy requirements before you can even do your fancy math? That's what Ticdat's for. Ticdat's there for predefining and validating all those fussy, not mathematically complex, those fussy, easy to understand requirements. So you don't have to worry about any of those things being violated when you do your fancy math.
And it's open source, right?
Ticdat's open source. I kind of feel like it's the sort of thing that has to be open source. I feel like, especially when Pandas is open source, and I can't really say like, oh, this is this can work as a shim library that sits on top of Pandas, makes Pandas better, and then it's like, oh yeah, you have to pay me for it. It's like, that would be ridiculous. So yeah, it's been open source from the beginning. I don't think it has a huge number. There's definitely some people out there using it. It's made its way into 4 companies. 3 of them because of me. So, I was part of a startup company, Opolytics, and that's when I first started using it. And then it was part of the OpEx tech stack, OpEx Analytics tech stack, where I was working with Mike. And then now we're using it at Foresta, and there's a company in Brazil, MIPWise, that's using it in a real similar way to how we're using it with Foresta, and which is also, all 4 of these companies are using it in a very similar way, where they just, in addition to making life easy for whatever you want to do with your code, it's also makes our life easy to say, oh, if you wrote some code that you want to turn into an app, if you just follow this Ticdat template, then our code can understand your code, and then it's easy for us to build an app around your code, right?
So that's in some sense, your tidy, tested, and safe is like the idea. Like you should think about this. And Ticdat is an implementation of that. Like one implementation. And I think you're going to do is like, if you do it some other way, you're cool with that as long as you follow these steps. And this is how you can make these things more implementable. And more
or at least it's kind of a different argument if you do it some other way, right? If you do it some other way and your code has like twice as much boilerplate as you would have with Ticdat, then we would have an argument as to like, why do you need so much extra boilerplate, right? But that's a better argument. That's a better argument, and it's not like anything, having twice as much boilerplate is like, it's not the most terrible thing in the world. Plenty of projects have lots of boilerplate and they work fine. But so I think it would be interesting if there were other libraries out there that were kind of analogous to Ticdat. I haven't found one. I think it's kind of, I don't have a good explanation for why something hasn't happened like that. But if somebody makes another open source package that's like, oh, this is like Ticdat, except I improved 18 different things, great. As long as it's open source, great. And I'll collaborate with that package as well. I mean, that's the idea behind open source.
Pete, have you seen kind of the flip side of what we've been talking about is, have you seen cases where people have done really good kind of OR work and simply not, for whatever reason, been able to satisfy the people responsible for the production systems and kind of things have gotten stuck there? Have you observed that?
I mean, this is going into the era of war stories that might hurt people's feelings. I mean, I think that I think there's a couple of things that can happen. One is that software engineers can be unhappy, but they kind of bury their unhappiness because they don't want to be mean to their colleagues. So I think there's kind of an unnecessary unhappiness that occurs, and also kind of unnecessary time wasting. It's like, this code is kind of a mess, and so I can't just plug it in. I have to like decipher it in order to plug in. It's like, you're making somebody unhappy, and it's also wasting time. But I mean, I'm always, with regards to safe, that's the part of it where I've seen drama. I mean, for sure. I mean, I'm always impressed by how often and how creatively real life users will come up with odd data mistakes that are really hard to anticipate. Like I worked with a project one time where I was doing Ticdat and I had all of my data integrity rules in place, except for just one. And just one data integrity rule was not in place. And it was like, I tried to put it in place, but I made a typo in my function. So so it wasn't checking the thing that it was supposed to check. And sure enough, that was the one, there's like, I was like, this guy put a 0 where there's not supposed to be a 0. It's like, I did everything else right. I wrote a tooltip and everything saying it has to be a positive number, and I gave it a column name that implied it's supposed to be a positive number. But sure enough, guy puts a 0 in there and I forgot to check, my code wasn't checking it. And, and there I am at like, 11 o'clock at night and, whatever, 11, some weird time of day for both of us because he was in India. And, he was like, we got to fix this. I need to fix this before you go on the plane tomorrow. And I was like, I don't know who to get mad at here, me or you. It's like, you put a 0 where there's not supposed to be a 0, but on the other hand, I'm the tiny tested safe guy. They're supposed to check all the columns to make sure there's not zeros. So it's like, and I mean, it's people do that stuff, and I think it's just so that's the one where I think you're going to have the most headaches if you don't check for those kind of stupid sanity checking problems, and that's the one I've heard most from other people whose careers, if I can flip it around and make it a positive way, like that's the one that I've some former colleagues of Mike Watson and I, where they talk about like, oh, how Pete helped me with my career. The one they come back to most of all is safe. They're like, oh, thank God I did that thing. Like this guy, it's like saves me so much time. I pass it to somebody. They make these like three mistakes that I think are simple mistakes, but sure enough, that's what people make. And we just fix those right away. And then we're moving on to a more interesting level of collaboration instead of wasting our time for, and creating bad vibes over who's to fault for the 0. Yeah.
I think kind of related to that, Pete, early on in the days of logic tools when we were working together, it's like, as we started finding bugs and things like, minimum and maximum number of warehouses, like people would switch those up and cause errors. We corrected that. And we also spent a lot of time on good error messages, like giving users feedback on where the problems were. And I think that led to a pretty happy user base and something that then your users can then take care of the problem without having to see infeasible and then call someone and try to figure out like what's going wrong.
Yeah. Although I want to be clear, like when I'm talking about safe, I'm not talking about infeasibility. Turns into some of the infeasibility conditions can be handled with sanity checks, like going back to the diet problem, like the max cannot be smaller than the min. If you don't check that, then what'll happen will be an infeasible model. But there's also infeasibilities that are sophisticated. So if you really want to be good with infeasibility, you have to come up with something mathematically sophisticated for how to handle it. That's a little bit of a different topic. But if you want to go back and talk about network design, I mean, the other thing we saw was that like our app wouldn't let you upload dirty data. You had to fix it before you uploaded it into our tool. And the Supply Chain Gurus app, like they were pretty loose with they let them upload. And after the dirty data was uploaded, it gave them like a comprehensive report on where the data integrity problems were. And users liked their method better. And so that's I've tried to use that method ever since, because that seems to be more natural to the user. Is like, I'm uploading data now, don't hassle me. I'm just building the data. Stop telling me I'm doing it wrong. Like, let me get all the data in one place, and then the next step is tell me all the things that are screwed up before I hit solve. And it's like, yeah, that's a better flow. And that's like, Don Hicks invented that flow as far as I can tell. So yeah, I credit, Don Hicks with that. Cool invention. So yeah, Ticdat was partially inspired by that.
So Pete, a question for you, pretty open-ended, and that is, how do you imagine software development for OR applications evolving in the age of GenAI?
Yeah, I mean, I think everybody likes to answer this question the same way, where they like to think that their job won't be replaced, but some other guy's job will be replaced, right? So that's the, So I'm not sure. So it's tough to say. Like, I definitely think I've definitely used LLMs to build MIPS, and there is a hallucination risk, and so. I don't know. It's hard for me to say you're going to like not have somebody that understands. Like, look, I agree the art of modeling is real. I just tend to think that people learn it by building models and figuring it out for themselves. But you're going to need somebody that understands the art of modeling, somebody that looks over the math, the Python part of the code, the sexy part, not the Ticdat part, but the sexy part, understands what's going on there. Because if they don't, I think you're gonna end up with like a bug that gets created by the LLM, and the LLM keeps hallucinating on how to fix that bug, or the bug doesn't get captured, right? So and I also think that if you like I said before, the LLMs, if you ask the LLM about any of these like less sexy stuff that I'm talking about, the LLM has really good answers for that stuff, because it's just a lot of it is just the world of Python, where LLMs are really well trained on the world of Python. And in fact, I've kind of gotten to the point where I don't do a ton of Python research right now. I have conversations with the LLM, and it's kind of, like I could share some of those conversations I have if people are interested, where I'm just like, for example, this notebook where I'm to some extent criticizing a Gurobi example as not being sufficiently safe, and, I had a conversation with the LLM where I was like, yeah, am I being rude to Gurobi here? And they were like, well, you could be a little nicer, but you have a point, So I was like, okay, I'll be a little nicer. I'm not going to change my core point, So I thought, and I also have worked with LLMs where they've had them do the work of who's our Larry? What's Larry's last name again? I always forget Larry's last name. Snyder, right?
Snyder.
Yeah. Or it's like, I don't know. Is the LLM replace Peter Cacioppi? I don't know. Maybe the LLM can replace Larry Snyder. I mean, I'm having an interaction with a colleague who is not that familiar with all the stuff in Larry Snyder's book, but I'm pretty familiar with it, and so is ChatGPT. So, I'm open with my colleague, as this is how we interact. She asked me a question. I double check the question makes sense. I bring the question over to ChatGPT as if I was asking Larry. ChatGPT gives me the answer back. I review it to make sure it makes sense in the context of our code, and then I pass it back to my colleague. I mean, I don't even pass it back to my colleague. I give her a link to that chat. Right. So I just have to make sure that there's nothing mean. I'm not saying anything mean about her in the chat. I'm talking to my digital version of Larry. Right. So, and so, it's helpful in all sorts of areas. I'm reluctant to think it's really replacing anyone. It's more like I think I guess I'm still in the camp of people that think it's making things more efficient and not, not replacing people or as much as increasing efficiency. I'm also reluctant to say it's even making a 10 times efficiency improvement.
Yeah.
I think it's more like there are certain things that come up where it's like, if the LLM is really good at this and you personally don't like doing that, then, hey, this is a great fit. Now it might even be a thing that you wouldn't otherwise do that now you'll do. Right. So that sort of situation, it's like more than 10 times improvement, but then that's not the same thing as saying it's having a consistent across the board 10 times improvement with all the things that you do. Right. So, but I
Well,
don't know.
Pete,
We can
you
have this
actually
conversation.
articulate.
We can have this conversation next year, right? Because it'll probably be different next year, right? So.
Yeah, right.
Well, I think you already articulated some things though in your description that you are fundamentally doing different in building optimization models than you were before LLMs.
The things that I'm personally doing different is I'm showing up. What I'm doing is I'm using it to show up the areas where I'm weakest. So first and foremost, it's like, I don't like reading like the elaborate documentation for how to do something fancy with Postgres. So I just take those conversations directly to the LLM. The LLM has read all the Postgres documentation and steers me quite well, right? And so in that sense, it's total a game changer. Like colleagues are like, oh, Pete's a Postgres expert. It's like, no, not really. It's like, I'm just willing to pay $200 a month. So it's not to have this headache. In terms of, doing sort of like, having somebody that's like Larry Snyder, it's not a 10 times improvement, but it does make my life better. Right? It saves me the trouble of having to like crack those books open and read them. In terms of writing my actual math code, I'm using it almost nothing for that, right? Because I kind of feel like, well, I have to read it over anyway, very carefully. Since I'm going to be reading it very carefully anyway, I'm just going to write it myself. So that's the way that's the way I'm doing it. Based on what I see on social media, it seems like there's really a mix, right? It's not like a consistent pattern. Some people are saying it's completely changing their workflow. Some people are more like me and saying it's only changing it in certain areas. So I don't know. Well, yeah, the future is a mystery, right? So I think I just think the verdict's out, right? It's not. I think the verdict's out. It's not like the way Python was like 5-6 years ago, where like, guys, it's taken over. Everybody get on board, right? I still think there are going to be great programmers out there that don't use it at all.
This was great. We love the conversation. We'll have to have you on again.
I enjoyed it too. All right. Thanks for your time, guys.
All right.
Excellent. Thanks, Pete.